I thought this was a pretty good opening. It kind of gave you an idea as we emerged from the darkness to the bright sun, STS-44, and our mission patch.
Getting ready for ignition here. I'm in the center seat and I'm holding up a mirror on my wrist like this so I can look out the back window to see what's going on below, to see what you see going on here, and also I can look out the front window. At liftoff, looking on this little mirror I have on my wrist, it's just like a great big flash bulb's going off. You can look backwards. From this point here, you look right into the flame trench where everything is going on. Then you pick up a broader perspective, you see the entire pad, and eventually when you roll over the way it is here, you see the beach and the waves go by, and so you see this shrinking image on your wrist as you move away from Earth. It's an incredibly nice picture. Most of the time when you're in very hot dragsters, you're not looking out the back window, but in this case, it's quite a scene.
And here at main engine throttle up, you can feel the acceleration as the main engines come back to 104%.
Every time I fly in this thing, I think that it's a piece of cake, but I'll tell you, every time I fly in it, I learn something new. Like the main engines do rattle a little bit. I used to say they felt like an electric engine down there.
I was really enjoying the ride, and then I looked over at Story about this time in the flight, and I said, "Story, how you doing?" And he said, "I'm scared to death."
The older I get, the more scared I get.
I was down on the middeck, and when the SRBs separated, as you see here, there were loud exclamations of all the flame coming into the window from the separation motors that flashed at the time.
Solid fire across those front windows.
It looks like a furnace when you look through the window at it.
And after we got into second stage, we didn't have the solids anymore. Through this mirror head out the back window, you can see the pulsations. The plume even grew, the main engines. And it's orange-yellow flame, and you could also see that light perturbated out to the front windows.
We're kind of looking out of the aft windows over the payload, and you can see the sparkly activity in the back. Those are ice crystals that are emerging from and around the main engines back there.
After about 2 hours on orbit, we, after finishing opening the payload bay doors, we were ready to start deploying our payload, which was the Defense Support Program satellite, which you can see coming into the light right now. It's an early warning satellite. It consists of basically an infrared telescope plus some other nuclear detection sensors, and it's used for early warning of missile launches. It was used extensively during the Iraqi war to warn us when Scud missiles were launched.
Here you see the payload cover removal system in action. It's kind of a fishing line type of arrangement. A motor pulls on the string and removes those cloth or canvas covers off of the nuclear detection sensors at the bottom of the payload there. They were real concerned about debris or contamination, the dust that floats around after you get up on orbit, getting on the lenses of the sensors and contaminating them. So that's the reason they had the covers in place. It worked flawlessly, and there were a lot of jokes going about fishing lines and so on with this. And they get tucked into the cone here, and then we shut it down. It was a one-time use, and I don't think we'll get to see this again, so enjoy.
Yeah, here we are raising the satellite up to 29 degrees. We tilt it up at an angle so that when we deploy it, it doesn't run into the orbiter structure. We do some checkout while we're in orbit with it, and the ground also does extensive checkout to make sure that all the communications are working and everything's functioning. Here you see the panel that we used for the deploy and checking off some of the many steps that we do in preparing it for the deploy of the satellite. Here it is at 58 degrees, the final angle before deploy. Those are the solar panels that you see reflecting the blue light. And here's the deploy. It separates from us at a very slow rate, drifts up away from us. The dark area is the satellite itself. The white and then the gold-orange nozzle below it is the inertial upper stage, which boosts it into its final orbit of around 22,000 miles. The IUS, which is built by Boeing and a program run by the Air Force, performed flawlessly. It was the best one they've seen to date. It worked very well, got it into its orbit, and the DSP is right now undergoing its on-orbit checkout and apparently is functioning very well. The satellite will continue to be a sentinel for us for many years up there, ready to watch for any missile launches that we may need to know about in the future.
I think we informally dubbed it Liberty.
Yes, and Story was very happy when we got the deploy off. He looked over mine and Mario's shoulders to make sure we did everything correctly. Here's the satellite about 5 miles away. We moved away from it. After we deployed it, Fred moved the shuttle up and away from it some distance, and we were able to watch it in the sunlight when the sun came up.
Well, here's the Army taking the ultimate high ground. Jim and I are shown here on the aft flight deck with Terra Scout hardware mounted in the overhead window. Terra Scout's a program with this first experiment designed to baseline the characterization of human observation techniques from Earth orbit. The results of this and future Terra Scout experimentation will be used to design a more human quality into future remote sensing systems. This is one of the targets we passed. This is Cape Canaveral. The skid strip at the Cape at this particular point was cloud covered, so we didn't get it.
Here you see myself installing the M88-1 radio antenna. This antenna was used with our direct comms to talk directly with people on the ground. The M88-1 experiment was a military experiment designed to get a quantification or handle on just how well the observer from space can see detail on the ground, and if that's needed in the future, we might be assigned to help in time of crisis. Here you see the camera that I used, the long barrel on that, and over my left shoulder there in the background you see the monitor, and there's some of the radio equipment we used, and on top of in the image that you see is the storage device for the digital images. And here's a picture of the first image that I took from 195 miles. That's the payload support team that was posing on the ground as we flew over.
This is a quick shot of 3 radiation monitoring experiments we carried, Sam, Cream, and Remy, and they're gathering data to better map the radiation environment around the Earth in low atmosphere, in low orbit.
This is what we call lower body negative pressure. It's exposing the body to subatmospheric pressure at minus 50 millimeters of mercury. It sucks the same amount of blood into the lower extremities as occurs when you're standing here in 1G, and that is able to simulate return to 1G on Earth here. It's also proposed as a mechanism for adapting us to Earth before we come home. And here is Jim, who is during a 4-hour soak, what we call 4 hours of exposure to that, has shown that he could work very effectively undergoing lower body negative pressure. And here's the commander, obviously running myself. One of the principal differences between this and previous lower body negative pressure experiments was to see how one would readapt to Earth. Here's intraocular pressure to measure the pressure in the eyeball as it changes in spaceflight.
It's not as painful as it looks.
This is a microbial air sampler. It has a fan at the front that collects a sample of air on a sticky strip like a piece of flypaper. And once a sample was taken, it was more fun just to see what the spinning fan would do in microgravity. Mario was on the treadmill at the time it seized up, and you'll see it seize here fairly soon. We were exercising to support a DSO and to have some improved capability on entry. And that's the last we saw of the treadmill. And this does look like the Atlantis Gymnasium, Space Gym. We quickly converted the treadmill to a rowing machine. We used that for one exercise session, and the ground came up with another maneuver called the D maneuver, which we used until the mission was terminated.
In zero gravity, the normal relationship between the visual system and the vestibular system of the inner ear is really changed dramatically. And this investigation studies how the brain learns to compensate for the changes in sensory system information about gravity, both during flight and after flight. And this particular task tested eye reflexes while vision was occluded by the goggles that I was wearing.
This is what we call the bioreactor. It's a chamber that whose cylinders, an outer cylinder and inner cylinder, rotate at different velocities, and there's also different flows through it. We're studying the hydrodynamics of 3 different sized spheres that run in there. The hypothesis is that we will be able to grow clumps of tissue cultures in space much more effectively than the monolayer of tissue cultures that we have down here on Earth, which will contribute to things like the study of cancer and also production of vaccines.
We had to fix a humidity separator on orbit. It's one of the devices that take the water out of our air and give us a comfortable relative humidity. Kind of bad shot showing the repair on it, but there's not much room down below the floor of the orbiter, down in the bilges. We had to go in and dry up all the water and then put a plastic bag over the outlet to the humidity separator in case it leaked again. We'd be able to contain the water and it wouldn't damage our equipment.
This will be the space station mirrors that came into view out our aft window. Now you can see it in the overhead window as it approaches the moon, which will come into view shortly. The ground had called this near miss up to us, and actually wasn't near. We were 25 miles away, but it was spectacular to see another vehicle coming so close to us. Our next event was a convergence with a Cosmos spent booster, and this is a scene in the middeck as we made the 7-second burn to open that distance from 3 miles to about 35 miles. And this just shows you the forces during a aft RCS jet burn.
We spent a lot of time at these overhead windows looking down at the Earth, both at the meteorology, the oceanography, and the dirt or landmass down there. One of the first things we saw was Uri, a tremendous super tornado, hurricane, cyclone, or whatever. We'll talk about more about that during the slides. And the eye of Uri.
That was one of the tallest eyes I'd ever seen. It looked like about 40, 50,000 feet tall, and at one time it had very, very sharp walls to it. Most impressive weather phenomenon I've ever seen from space. Here we are over Central America, Panama Canal down there. We're going to zoom in and look at it. It's very difficult to get pictures of Panama because it is so cloudy most of the time. My zoom technique is not as good as it might be there. Here is a dual camera mount in which you can fire off two cameras simultaneously, and that's a way of testing different ways of taking pictures. So you take the same picture and you can evaluate things like different kinds of films and different camera techniques.
You get a feel for the work environment there. You see Tom Hennon alongside Story viewing out the window, both work going on simultaneously. Here you see some clouds, and these are over the Pacific, and it depicts a jet stream. The initial reason we took the clouds was a picture of it was for its beauty, and there's some scientific information in there also.
This is coming from the Atlantic over Morocco, over some desert area. Story was taking this, and he found some really interesting sand dunes to photograph with the ARRI. Since those show up so well from space, we expect that they are very large sand dunes.
Like 200 or 300 feet tall.
Yeah, spending time at the window was one of the recreational activities on board. Here you see Tom Hennon using a large pair of binoculars and myself taking some Earth obs photos. And in this image, you see some thunderstorms that we see at night as we go over the dark side of the Earth. They show up quite dramatically and really show up well in our imagery.
Story loves shrimp, and he had all of it, and I wanted some of it, and you don't see the whole sequence, but I actually begged for it. And I was so happy when he gave it to me. It wasn't unusual for him to have 5 or 6 of these things aligned, waiting for him to eat.
But I didn't get to eat all of it.
We all shared Story shrimp.
This was our Thanksgiving dinner, and we hope we enjoyed it at about the same time you did. It's always, Story said it's always great to be in space and Thanksgiving, but he's always happy to be in space all the time.
This is the only time we got to sit down together.
Everyone knows that the U.S. Army probably does more before sunrise than most people do all day, and with 16 sunrises a day, it has to be obvious how much work Jim Voss and I did on this flight. Well, our day was only about half over at this point, while the rest of the crew was probably ready for a snooze after that hearty Thanksgiving dinner. I was compacting dinner as well as probably 6 man-days of trash at this point. The compactor shown here proved invaluable in the management of trash on our flight, and I believe it will become a necessity for longer duration flights. We also carried a new food packaging product on this flight, and that together with the compactor really enabled us to manage our waste and our trash. And we're pulling it out, and again, this is about a little over 6 man-days worth of trash, and
we have a supply of water, either supply water created by the fuel cells or liquid water from our from our way system, and we did a dump over Houston. Maybe you saw it on Thanksgiving evening.
My 4-year-old sent up a message, where'd you get the fuzzy tail, when he saw us go by with a dump in progress.
So we're kind of floating up onto the flight deck. We're preparing for deorbit, and we've put in the rear seats, all of the wires and all the hoses, and I'm over here in the commander seat getting ready for some of the activities that will occur the next day, and it includes a lot of inputs onto the through the keyboard onto the computer, and obviously I must like it because I gave you a thumbs up on it.
This was a real-time sunset in the payload bay, but this glow afterwards was moon glow.
Here we are getting ready for our deorbit. We had several of us, 5 in fact, do medical experiments on the way down during entry. This one involves looking at our orthostatic function during entry and post-landing. It involved putting this instrumentation on during our deorbit prep in our suit and through the suit, and then measuring our heart rate and our blood pressure during entry. And then after putting our instrumentation on, we had to put our suits on. We'll show you just a little bit of the struggle of working in zero-G, trying to get, in this case, Story into his suit. He's braced against the seat there, and I'm struggling with him, and most of the time it took Tom holding him in place to get the other part of his suit on.
Now, you've seen some of the activities that we do pre-landing. We get up 7 hours before we do our deorbit burn, and during that 7 hours we're extremely busy, generally getting the orbiter ready to enter, getting ourselves suited up, changing our computer mode from orbit to entry, and then the actual entry.
This is a shot looking out the commander's window. We're about 240,000 feet going across Hawaii at this point. The islands were cloud covered, but you can get a sensation of how fast we're going across the surface of the Earth.
On the hack, we're above the desert at Edwards. This is just a big cylinder above the landing runway. You can see how the orbiter is shaking. Every now and then you can see the back seat of the pilot's seat shaking. I don't think we're aware of that vibration, though, inside.
I was. That camera that I was holding taking these pictures weighed about 50 pounds at this point.
Okay, that's looking down at Edwards, the complex, right at the bottom of the picture, and then the lake bed that you'll see out of the upper portion of the picture. We are about 400 feet above the ground. We push the button to deploy the gear at 400 feet, and the gear should be down about 300 feet above the ground. Then it's just a matter of coasting this kind of brick into a landing.
Fred makes it sound easy, but it was great to sit there and watch him complete this task. This was one of the best. This was one of the best program, and this was to a runway that we practiced very few approaches to.
You can see the dust coming from the lake bed. Nose gear comes down. It touches down about 140 knots, and then one of our objectives was to look at the hardness of the runway there, and you do that by just letting the orbiter land on it and then roll out. We didn't apply any brakes at all, and this is a view from inside as we're still coasting. I saw the end of the runway come up, and I asked Houston if we could put the brakes on. We did that at 15 miles an hour.
That's a welcoming committee.
Yeah. I didn't even know they were there.